Find the length of the hypotenuse of each right triangle shown below by using the Pythagorean theorem, which is what we were just doing. Leave your answer in the simplest radical form. So this is how we would find the unknown side lengths, which is kind of what we did in the last lesson as well. All right, so again, we have our right ankle. I've got this leg and this leg right here. Now this one does not show the areas, so I could just draw the two squares like these.
That's surprising.
So this area is going to be 9, very good. And this area would be 16. So if I wanted the hypotenuse area for this square up in here, something like this area would be what? Well, I'd do 9 plus 16, which is 25. So if I want the side length, I would square root 25, which would be 5. So C in this case, the C that we have right there is a 5 units. Done. Alright, this one's going to work exactly the same way. Here's a leg, here's a leg, because these two legs make up the right ankle. So again, if I want to, I could draw a square right here, and then I could draw a square right here. And if my side length is 9, then the area of that same square would be 81. If I had a side length of 12, then the area of the square would be 144. But what I want is the C value, so I do need to figure out the area of this square.
Wait, so you just times it by itself?
The area of this one would be the 81 plus 144, which turns out to be 225. Now if you square root 225, that'll give you C. But the calculator will tell you that it's exactly 15. So that is the actual answer that we have. Alright, 3 I'm going to do a little different. Let's look back at the Pythagorean Theorem. So in this one, again, it gives us the two legs, which is pretty crucial to know. So I'm going to replace the A with the 7. And then the B will be replaced with the 8 because they are both legs. Now when I square these, I've got 49er plus 64. This would equal C squared. And then when I add these two together, I should get 113. Now this is the hypotenuse squared. So this would be the area of the square for the hypotenuse. So to solve these, all we need to do is square root both sides. And then we'd get C is the square root of 113. That is our answer. Now if I could, I would try to simplify this, but 113 can't be simplified. So it will stay as is. Alright, number 4, again we're looking at the two legs right here, which are given. So if I wanted to, and you guys seem to like this method with the squares. So what's the area of this square if the side length is 6? 36. But then we got this other one right here. What would be the area of these? 4, right? Now we want the hypotenuse, and we can make a square out of these. So how do we find the area of the hypotenuse square? Alright, good. 36 plus 4. That's close. If there were squares to count. Otherwise you just get 1. This one is 40. So C is going to be the square root of 40. But let's check to see if the square root of 40 can be simplified. So I'm going to split this up into 2 and 20. And then this splits up into 2 and 10. And this splits up into 2 and 5. So the square root of 40 is really the square root of 2 times 2 times 2 times 5. Now, is there any pairs in this?
Yes.
Alright. So the way I heard this was that these two 2's are the same. So they're going to go out on a date as one date. The other two, the 2 and the 5, aren't compatible, so they can't go on a date. So we just multiply those together to get 10.
The 5 got rejected by the 2.
And the 2 got rejected by the 5, I suppose. Look, I didn't make that up. Someone else did. You can like it if you want, but you don't have to, all right? All right, number 5, we're going to use the equation for the Pythagorean theorem. A squared plus b squared is c squared. And it did give us the 2 𝐿𝑒𝑠𝑠. So let's go ahead and replace a and b. All right, so this may be where a calculator comes in pretty nice, but if we do square these, we get 0.64 and 0.36, which now we need to add. And when we add these, I get 1.00. Now this is c squared. What we want though is just c. So we got to square root this, and we find the c value is also 1. So I'm going to use the squares, but yes, if you want, you can use the other way. So I'm going to make a square radical. Since the side length is 5, I know, it's not perfect. There, this one would be 25. This side length is the square root of 11. Now I could put that in my calculator, the square root of 11 squared. The area of that square is going to be 11. So the hypotenuse, if we make this a square, I can do it. I'm close. The area of this would be the 25 plus the 11, which is 36. So the hypotenuse itself is the square root of 36, which is 6. Alright, this says that we should be using the Pythagorean theorem. We have been the whole time, so it's not a problem. But we may have to simplify these into, well, simplest radical form. Alright, so I got a squared plus b squared equals c squared. However, on this one, notice we got this leg, so I can replace one of the legs with 5. But this other length, radical, this is the hypotenuse. So I need to replace the c in this case with 13. So let's go and square those. 25 plus b squared equals 169er. Now if I'm solving for b squared, what I need to do is subtract 25 from both sides. So subtract 25 radical and subtract 25 radical. Now this is b squared is 144, but we just want b. So we're just going to square root both of these, which leaves us with b. I guess it was a, wasn't it? 12. But remember, the legs don't matter, so we'll say a is 12. It doesn't matter.
Is that 144 simplified?
Square root of the square root of 144 is 12.
Can you try units?
I mean, I could go back and replace those. There we go. Alright, this time we are solving for the b value. So we'll acknowledge that the 24 is a leg because it's part of that right ankle area. And c is the hypotenuse because it's opposite the 90-degree ankle. That value is 25. So let's go ahead and square these. So we got 576 plus b squared equals 625. And to solve with these, we will subtract 576 from both sides. So that leaves us with b squared equals 49er. And now to solve for b, I'll square root both sides. And that leaves me with b equals 7. Here we go. On number 9er, we'll go ahead and use the same equation on this one. Now we'll replace the a on this one is this leg radical because it makes up that 90-degree ankle. That's 0.12. And the hypotenuse in this case is this 0.2. So let's go ahead and square these. So this one would be 0.0144. And squaring this one would be 0.04. Alright, now to solve this, I'm going to subtract 0.0144 from both sides. Alright, so there we go after we subtracted that 0.0144. And finally, to solve these, we'll square root both sides, which gives us just the b equals 0.16. That gives us the answer. Alright, so in the Pythagorean Theorem, I'm going to replace one of the legs with 4, and the hypotenuse is the square root of 41. So let's square these. This is 16, and that's 41. A squared plus 16 is 41. Now to solve for a squared, I need to subtract 16 from both sides. Again, that's to find the area of that one square. So I got a squared is 25. And then I'll square root both sides to get just the a value, which is 5. Alright, this one, instead of using a, b, and c, they have an x value, which is just an unknown. And in this case, they gave us both the legs. So I have 8 and 15 on that. So 8 squared and 15 squared. So let's go ahead and add 64 and 225, which then would give us 289er. That sounds like a perfect square. Let's see. So when I square root these,
17.
I get c is 17. That's it. Yeah, sorry. I put c because it was the hypotenuse. But yeah, they used x. So there it is. Alright, here we go again. A squared plus b squared equals c squared. I've got a leg at a value of 10. And this is the hypotenuse at 10 square root of 2. 10 times the square root of 2, that's in parentheses squared. And b we'll say is the x value. So 10 squared is 100. And in the calculator I could put this 10 times the square root of 2 squared, but let's just square both of them. So I got 100 times 2, which is going to be 200. I squared the 10, which gave me 100. I squared the square root of 2, which is 2. And when I multiply 100 and 2, I get the 200. Now we're going to go ahead and subtract 100 from both sides. Alright, let's go ahead and square root both of these. And I got x is 10. Done. A squared plus b squared is c squared. And in this case, a and b are both x's. And the hypotenuse is 20. So I'm going to replace that with 20. Well, 20 squared is 400. How do I know? Because I put it in the calculator. Now, if I had x squareds, in terms of x squareds, I've got one there and one there. That's 2 of these x squareds. So, before I do anything else, what I need to do is divide both sides by 2, so I just have x squared. The 2's cancel. Or it gives us 1x squared, which would have been the same as 200. Now to solve, I must square root both sides, which gives me x equals, oh, we got to break that down, don't we? 200 square root breaks up into 2 and 100, which breaks up into 2 and 50. That's a 2 and 2, which breaks up into 2 and 25er. Oh, 25 is not prime, but the 2 is, which is 5 and 5. So the square root of 200 is really the square root of 2 times 2 times 2 times 5 times 5. And like we said before, these two can go on a date, and these two can go on a date. Multiply these, and then this loner is left alone.
Third wheel.
The third wheel, that's for cube roots. 2 times 5 is 10, and then we got the square root of 2 up in count. That is the answer. Alright, so blocks are requested on a 𝐺. And 2.1 is a leg, so I got a square radical. And this appears that if I squared it for my area, on this one I'd get 4.41. The 2.9 though, that is a hypotenuse up in count. So let me see if I can draw that a little better. So my area is 2.9 times 2.9. So what this means is that this green square plus this other green square has to equal 8.41. So the area
It's 4.
of a 𝐺,
It's 4.
yeah, it is going to be 4, right? 8.41
Would it be
minus the 4.41, which is 4. Now if the area is 4, what is the actual length of the
2.
square? 2. So x is 2. Find, fix, and justify. Megan was asked to solve for the unknown side length in a triangle below. Her work is shown below. She made a mistake when solving. Explain the mistake she made and then solve the problem correct. The making mistake. Alright, the original mistake. Alright, the 13 is the hypotenuse, not the leg. So right account, they made a mistake. So if we were to correct these, we'd have 5 squared plus b squared equals the 13 squared. So that's a 25 and there's 169er. And then subtracting 25 from both sides. So b squared is 144. And to solve it, we'll just square root both sides. And we find that b is 12. Find, fix, and justify. Raffi was asked to solve for the length of a hypotenuse of a right triangle with legs that have side lengths of 4 and 5. His work is shown below. He made a mistake when solving though. Explain the mistake and solve the problem correct. Bam, we can see that everything was done correctly except Radham. Raffi needed to square root the 41 at this point because it would have been c squared. So continuing at these, we can square root c squared and also square root 41. And we see that c is the square root of 41. This can be simplified, so that's the answer right there.